So in this video, we're going to discuss some of the Cisco proprietary enhancements to the standard 802.1d spanning tree. I put this in its own separate special video just so you would know that these are enhancements. They're not part of the core protocol, but most every manufacturer supports them. Now, the main reason that Cisco implemented these enhancements to spanning tree is that standard 802.1d spanning tree takes a long time to bring a port into the forwarding state. You'll recall in the previous video where we talked about the various port states and how long it can stay in those states, that by the time a port actually makes it to the forwarding state, the workstation / server / phone / refrigerator or whatever device you have connected to that port has timed out and is assigned an address from that 169.254 IP address range. And as you probably know, that range really doesn't work on most networks, enterprise or otherwise. Now, this is the main issue that Cisco has fixed with their enhancements to spanning tree, but there are other issues that regular 802.1d spanning tree presents that are also addressed by these spanning tree enhancements. Now again, these are Cisco proprietary. Most other vendors have similar functionality. For example, Juniper and HP have what they call edge ports, LACP, and BPDU protection. And those correspond to PortFast, Ether Channel, and BPDU Guard respectively. So the first enhancement we're going to talk about is Ether Channel. If you've worked around any mid-size or large networks at all, you've probably run into an Ether channel. And essentially, an Ether channel bonds multiple physical interfaces into one logical interface. You can have up to 8 interfaces of varying speed and capacity in this Ether channel. Now, the advantage is that this logical interface is seen as one interface to spanning tree. Therefore, if one physical interface in the channel fails, spanning tree doesn't kick off its reconvergence process and take up to 45-50 seconds to start forwarding traffic again. And again, that's the big advantage to Ether Channel. The other advantage is it also allows you to take advantage of all of the multiple links between switches and load balance across all of those links between your two switches. The next enhancement we're going to talk about is called PortFast. And PortFast is an interface level configuration that immediately places an interface in the forwarding state once something comes online. Now, this completely bypasses all of the STP convergence time that can take place when a link changes. It allows devices connected to the switch to come online immediately. As soon as the switch port gets power, the interface comes up and you can get an IP address or start sending data across the link however it's configured. This is only suitable for end-user facing ports, as it's very easy to create loops in the network because the switch doesn't do its listening and learning and doesn't block if it sees a BPDU and so on and so forth. It just comes up and immediately starts sending traffic. And if that happens to be a port on the same switch, then you're going to have a big loop in your network. It's for this reason that Cisco implemented another enhancement that kind of goes hand in hand with PortFast, and it's called BPDU Guard. BPDU Guard listens for BPDUs on an interface that PortFast is enabled on. It shuts down the interface if it detects a BPDU on that interface. Essentially, if it detects that another switch is connected to what should be an end-user edge port, it just cuts it off at the knees and says, "I'm sorry, you can't talk to me because you are not an end-user device." The last enhancement we'll talk about is called Root Guard. And honestly, I don't think I've ever used Root Guard on any network I've ever administered or designed. The possibility of breaking the network, in my opinion, is just too great. Root Guard is configured on interfaces that could never, ever become the root ports. And honestly, that one description right there is why I never use it, because I can always foresee a situation or a type of failure where any port that's connected to any other switch could possibly become the root port, unless it happens to be to a switch that has no other connections except through my switch. And essentially how Root Guard works is it listens to the BPDUs coming in from the neighbor switches. If a port has Root Guard enabled and the switch receives a superior BPDU on the root guarded port, i.e. it receives a BPDU from a switch that says, "I am the root bridge, you should send all of your traffic through me," then the switch with Root Guard enabled says, "I don't think so," and it just disables that port entirely. Now, it still listens to the BPDUs coming in on that port. And if at some point in the future it stops receiving that superior BPDU on that port, it will re-enable the port and continue processing. Used properly, RootGuard can really secure your network from malicious intruders, from misconfiguration, from failures. However, used improperly, you can kill your network, and I've actually done it in a lab. I have split a network in half, and I had 2 bridges that thought they were root bridges because I had RootGuard configured incorrectly. Like I said, you'll probably never ever use RootGuard, but it's on the exam, so I got to put it in the video here. So that's the configuration of RootGuard in a nutshell, and that concludes our discussion of Cisco's spanning tree enhancements.